All right, let's get started on today's meeting. So what we're going to be doing today is we are going to continue our look at displaying data. Last time we started off with a look at how to effectively display so that you can effectively communicate qualitative data, categorical data. And today we are going to take a look at how to display quantitative data, data where your variables actually take counts or measures or quantities of a particular characteristic. So this is all in service of what is known as descriptive statistics, which is basically the idea of being able to boil down large groups of numbers, large collections of data into something that is manageable, number one, for our human minds, and then number two, as a way to communicate to other individuals. So the one thing that you never want to do in psychology, especially as a science, is find out something amazing and then keep it to yourself. We're all about communicating our results, our findings, so that they can have the greatest impact out there in the real world. And in the real world, you have real human minds that don't really understand large amounts of data. So we are now working on the skills where we can simplify that data and present it in a way that makes sense to your typical human mind. All right, so that's what we're going to be looking at today when we're looking at displaying quantitative data. So the plan for today is we're going to start with how do you display just one quantitative variable. So if you only have one variable that you're looking at and you want to know more about that, you want to summarize a vast quantity of data, but just on one variable, we're going to see how you can use stem plots, dot plots, and then histograms. And then we're going to double down on that and take a look at displaying relationships between two quantitative variables. And displaying relationships between variables in general is one of the gold standard goals of psychology. So we are going to see how to do that with two quantitative variables today when we take a look at the scatter plot. But first, we are going to have a false memory callback. So we're going to call back to the Loftus and Palmer study that we looked at last time when we were discussing categorical data, because there is a real life example of false memories going on here. And we are going to take a bit of a deeper dive into that because it is a very unique opportunity. So let's start that up. So just to recap what we looked at last time, we introduced the Loftus and Palmer reconstruction of automobile destruction, an example of the interaction between language and memory. And this was a study that was reported where viewers saw a car accident displayed in a video. So they watched a video of a car accident. And then 1/3 of the participants were asked how fast were the cars going when they smashed into each other. 1/3 of the participants were asked how fast were the cars going when they hit each other. And then 1/3 of the participants were not asked about the speed of the cars. And then 1 week later, these participants were brought back. And this time, all of them were asked by the experimenter, did you see broken glass? And there was no broken glass in the video. So the idea was, could the way that the question was phrased initially, smashed into each other, hit each other, or no question at all, could that somehow interact with your memory so that now you would have a false memory of whether or not you saw broken glass? And as we saw last time when we were looking at how to display categorical data, the frequency with which participants said, yes, I did see broken glass, in other words, the frequency that they had a false memory was highest in the smashed condition and did not differ between the hit condition and the control condition, very clearly indicating that the way that you phrase a question gets incorporated somehow and interacts with your memory and actually changes what you remember about a particular event. So after this, at the end of our last meeting, I told you a story about one of my favorite studies that Loftus did, where they were able to implant a false memory into a participant simply by repeatedly over numerous interviews, asking them to tell me about the time that you were lost at the mall. So I relayed the story about how in interview number one, Loftus would ask the participant, a bunch of questions and then get to the question that they knew did not happen because they had the parents' stories about the child to draw from. So they knew this was a child that never got lost at the mall. First interview, they were asked, "Tell me about the time you were lost at the mall," and they denied ever being lost at the mall. Second interview, they were just asked again, "Tell me about the time when you were at the mall." Once again, would deny being at the mall. But then as the interviews progressed, just that one question made them less and less sure about whether or not they got lost at the mall, to the point where eventually they fabricated a false memory of being lost at the mall. And then not only that, but when they were presented with their previous audio recordings of their interviews, they denied that they were not ever lost at the mall. They were adamant that they had been lost at the mall, that it was a real memory. And that was accomplished just by asking that question over and over and over again. So I remember just being absolutely fascinated by this study when I first heard about it. And I thought to myself, the way that I do a lot of the subjects that we take a look at in this course, I wanted to take a look and see if I can find the original study. So a very good practice is to, whatever you are interested in psychology, go to the original studies. Do not go to textbooks. Do not go to reviews. Go to the original studies to see what was actually said, because you would be amazed at how much those reports oftentimes get distorted. So that's a practice that I stick to. And I thought to myself, you know what, I'm going to go and I'm going to find this paper just so that I can, show it to you and say, well, here's the original. There you go. And this is what happened. I found this paper here, The Formation of False Memories by Loftus and Pickrell. And in this one, I found the description of their study, and I'll just read it to you. It goes, the subjects in this study thought they were participating in a study of the kinds of things you may be able to remember from your childhood. The subjects were given a brief description of 4 events that supposedly occurred while the subject and a close family member were together. 3 were true events, and 1 was the false lost event. So this is not the study that I described. So this is a study that's kind of like the study I described, but instead of just asking, tell me about the time, instead of just asking, tell me about the time you were lost at the mall, they were actually given a description of a time that they were lost at the mall. They were actually reading a description of these 4 events, one of them which was the false event where they were lost at the mall. So that doesn't quite fit with the story that I told you. I was unable to find another study where Loftus actually just asked this one question in a series of interviews. So then I thought to myself, well, maybe other people have done this. And I found this experiment, False Memories of Childhood Experiences, by Hyman, Husband, and Billings. And once again, I'll just read the description. At the beginning of the first interview, so this one was interviews, at the beginning of the first interview, subjects were informed that in both interviews, they would be asked to recall and describe a set of childhood experiences based on information obtained from their parents. For each event, subjects were first cued with an event title, for example, family vacation, at age 5. If the subjects were unable to recall the event or if what they described did not appear to agree with the information provided by the parents, they appeared to be describing a different vacation, brief additional cues were provided. So that fits more with the description that I gave you. So they were simply asked, hey, can you remember the time you were lost at the mall when you were 5? And then they would stop there. And then if they were unable to recall that event, they would get additional information, or if they were describing the incorrect event, they would get additional information. Brief additional cues were provided, location, 1 or 2 activities, and other people involved. If the subjects were still unable to recall the event, the interviewer moved to the next event. The false event was presented in the same way as other events. So this is much closer to the description that I gave you, but this does not have the repeated interviews. It only has 2 interviews, so technically repeated, but it doesn't have that series of interviews, and it still gives a little bit more information than just tell me about the time you were lost at the mall when you were 5, for example. So then I found another study, the effects of stereotypes and suggestions on preschoolers' reports And in this one, what they did was they had 3 to 6 year olds, and they were in a situation where an event happened. And this event was that this individual named Sam Stone came into the room that they were in and did some behaviors, but importantly, did not rip a book and did not get their teddy bear dirty. So why did I mention that? Well, it's because what happened after this event is that during the interviews, children in the suggestion group were provided with 2 erroneous suggestions about what occurred during Sam Stone's visit. So the first misleading suggestion was that Sam Stone had ripped the book, and the second was that he had soiled the teddy bear. So this person that was named Sam Stone came into the room, did some stuff, did not rip a book, did not soil a teddy bear. And then later in the interviews, they would get suggestive questions, such as, for example, one week children were asked, when Sam Stone got that bear dirty, did he do it on purpose or was it an accident? And in the following interview session, they were asked, was Sam Stone happy or sad that he got the bear dirty? So once again, kind of like the study that I described to you, but once again, just doesn't have the entire group of, or the entire description that I gave to you. So it was at this point that I came down to 2 possible conclusions. Conclusion number 1, my story that I gave you of one of my favorite studies that I have ever heard about that Loftus did was actually never done. And it is just a conglomeration of different aspects of different studies that have been thrown together. And I have now created a false memory in my own mind that I have now possibly perpetuated in you, unfortunately. So trying to pull back that damage a little bit, but it is quite possible that that study never actually occurred. And I have formed this false memory by picking up different pieces of different studies and just amalgamating them together into a study that I remember hearing about in my undergrad education, and but didn't actually ever happen. So one possibility is that it is a actual false memory. So kind of like a meta example of exactly what we were talking about. The other possibility is that I actually did see this study described, but it was described in a documentary that has somehow been lost to the internet or is just not archived in a way that makes it easily searchable. So it's quite possible that I saw this in a documentary and I am remembering it correctly, but it's also possible that I just kind of Frankensteined a false memory together out of bits and pieces of other false memory research, of which I know that Professor Elizabeth Loftus is one of the pioneers and giants of that particular research. So quite possible that there is a false memory. And just to kind of drive home the idea that false memories are very, very difficult to detect. So this is from the Lichtman and Ceci Sam Stone study. This is the one where the individual Sam Stone did not rip a book and did not soil a teddy bear. As part of this study, they took the descriptions that the individuals give. They took the description that these children gave of the incident about Sam Stone, and they asked the question, well, can adults detect the inaccurate reports? So this was at 2 separate conferences that they did this. And they say, so seemingly believable were their reports that we presented videotapes of 3 of our participants, a 3-year-old, a 4-year-old, and a 5-year-old, to 119 researchers and clinicians, and this is the extreme part here, who work in the area of children's testimonial issues. So these were not lay people, these were people that were experts in the field of children's testimony. So they presented the videotapes to these clinicians and researchers who work in the area of children's testimonial issues to see if they could discriminate between the erroneous reports and the accurate ones. Could they determine which reports were false memories and which ones were not? Well, the answer is that the majority of both audiences from both conferences could not reliably tell overall whether the event reported by the children had occurred or not, nor could they identify which children were on the whole most accurate. So even experts taking a look at child testimony could not tell which of those testimonies was false and which of them were true. So how much less can we ourselves take a look at our own memory and our own testimonies and be sure about which memory is true and which one is false? So those are the two possibilities. So once again, this study, my memory of it could be based on nothing but a fabrication coming from a bunch of different studies coming together, or it could be from a long lost documentary. So if anybody in their academic career comes across that documentary, if you're in a class maybe a year from now and you're watching a documentary on memory and this occurs, please email me, let me know. But until then, the mystery will continue because I have no way of knowing, is this something that I have created a false memory of? Or is this an accurate memory just of a long lost documentary? All right, so that was our callback, our meta example of psychology in action. And now we're going to continue on with the displaying quantitative variables. So just to quickly recap what a quantitative variable is. A quantitative variable is a variable that takes number values that are actual quantities. So they're not number values that put you in a category like first, second, or third. These are actual number values that are quantities. They're counts or they're measurements. So the example that we saw with the pseudo patients and the being sane in insane places study was length of stay. And the 8 pseudo patients, they varied in their length of stay, hence a variable, from 7 to 52 days. And importantly, those 7 to 52 days with a mean of 19, those are quantities. So the bigger the number, the longer the time that they actually spent. It lets you know how long they were in that particular hospital for their stay. All right, so that's a quantitative variable. So how do we display those? Well, to illustrate the ways to display this, we're going to take a look at another study. And this study was a very interesting study that had to do with face shapes. So this is a study that took a look at whether or not there are characteristics of a person's face where you can take a look at them and predict whether or not they're going to be aggressive, whether or not they're going to show aggressive behavior. And this is not something in terms of a facial expression. This is something in terms of the actual structure of their face. So could you take a look at this individual here and predict reliably that you are, if you're going to interact with them, you are in store for a very unaggressive interaction, or you better prepare yourself because you're going to have a very aggressive interaction. So the study we're going to take a look at has a great title, In Your Face. Facial metrics predict aggressive behavior in the laboratory and in varsity and professional hockey players. So what they found is there was recent studies of sexual dimorphism in facial metrics that is independent of body size. And because of that, these individuals, Carré and McCormick, conducted 3 studies to examine the extent to which individual differences in the facial width to height ratio were associated with trait dominance using a questionnaire, or more importantly for our example here, aggression during a behavioral task. So does your face predict whether or not you're going to be aggressive during a behavioral task? So in other words, does face shape predict aggressive behavior? That's what we're going to take a look at. Another way to say this is there such a thing as resting A face, where the A stands for aggression? So can you just look at somebody and because of the structure of their face, know that they are in general an aggressive person or in general not an aggressive person? So let's take a look at the study before we start taking a look at the quantitative data that we're going to be displaying. So this is the study. This is a page from the study, and this is how they measured the facial width to height ratio. So their measure of the face that they were using was the width to height ratio. So what they did is they drew vertical lines, and those represented, so they would take photos and then they would draw vertical lines that represented the right zygon and the left zygon. And that was a word I definitely knew before yesterday. But in case you don't, a zygon is the specific anatomical landmark on the skull defined as the most lateral, that is outermost, point of the zygomatic arch, which is, in other words, the cheekbone bone. So if somebody has very prominent cheekbones, next time, instead of saying, oh my goodness, your cheekbones are so high, you can say, wow, look at those zygons. Those are some high zygons. All right, so right zygon, left zygon, and then they also determined where is the upper lip, and then where is the bottom of the brow, and those are the measurements that gave them the width to height ratio. So right zygon, left zygon, that gave them the width, and then upper lip to lower brow, that gave them the height, and then they took the width, they divided it by the height, and that gave them their facial width to height ratio. So this is a quantitative measure because it takes on actual measurements and turns it into a quantity that tells you basically how wide is your face compared to how high is your face. All right, and I fully expect everybody to go home tonight and measure their faces in the mirror to kind of figure out, am I going to be aggressive or am I not going to be aggressive? All right, so that was the measure of face to facial width to height ratio. The other measure that we're going to take a look at, another quantitative variable, was a measure of aggressive behavior. So what they did is they put these subjects into a situation where they could either act aggressively or they could act non-aggressively. And then they measured, well, how do they behave in this particular situation? So the measure that they used is called the point subtraction aggression paradigm. So I'm just going to read a little bit of it so you can see what we're dealing with. So it says to measure aggressive behavior, we use the modified version of the point subtraction aggression paradigm. This measure is positively correlated with various self-report measures of aggression. What that means is that it matches up with how aggressive people think that they are. In brief, participants were led to believe that they would be paired with a same-sex partner, in actuality an E-prime computer program, on a task that required them to select among 3 response options to earn points that would be exchangeable for money. So not to go into too much detail about how this is calculated, because it does get a little complicated. Basically, you had options about how you interacted with what you thought was another person. And those options were either aggressive options or non-aggressive options. And after a series of interactions, you basically got an aggression score. So during that interaction, did you behave aggressively? If so, you got a higher score. Or did you behave non-aggressively, in which case you got a lower score? So they had these 2 measures, these 2 quantitative variables. They had facial width to height ratio. They had the point subtraction aggression paradigm aggression measure. And then they wanted to see if those 2 were related. And what they found was they wanted to know, again, does face shape predict aggressive behavior? And what they actually found was that it actually does. There is a relation between the 2. Your face shape actually is related to aggressive behavior. But interestingly, they did this for both males and females. And what they found was that for males, that relation existed, but for females, there was no relation. So females varied in the amount of aggression that they showed. You had some very highly aggressive females. You had some females that were not aggressive. However, that aggression behavior was not related at all to their facial ratio. The width and height of their face had no predictive ability on whether or not they were going to act aggressively. So because of that, we are going to stick with just the male data for this time around. And what we're going to do is we're going to start with the aggressive behavior scores. So eventually we're going to get to where we can see a relation between the 2 scores, aggressive behavior and the facial ratio. But we need to go through some ways of displaying one quantitative variable. So we're going to start with the aggressive behavior scores, and we're going to see just how aggressive were these individuals, these males, and also what kind of distribution of aggression was there. Was everybody equally aggressive? Was everybody equally non-aggressive? Was there an even spread? how were these scores distributed amongst the individuals? All right, so the point subtraction aggression paradigm, as we mentioned, higher score equals more aggressive behavior. There were 37 subjects, and there are their scores. So once again, I put this up because looking at this, it is extremely difficult to take a look at that and say, oh, okay, yeah, I see the pattern. I get it. There's more scores over here and there's fewer scores over here. I can totally see that. We can't. Our minds are not made to do that. So what we're going to do instead is we are going to take a look at this and see how you can communicate this in a much better way. On that note, before we get to how to display this data actually came from the original study. The data actually came from this figure right here. So I'll just explain a little bit of this figure here, and I'll explain a little bit of how we got that data. So this figure is a scatter plot, foreshadowing. We're going to see more about this later on. But basically, on the x-axis here, you have one quantitative variable. That's the face width to height ratio. And then on the y-axis over here, you have another quantitative variable. That is the aggressive behavior score. And then each of these dots represent a particular individual. So that dot right there, that is one of the males that participated in this experiment. And those are his aggression scores. So he almost scored a 400 on that aggression scale. And he has a face width to height ratio of just over 1.65. So the way that you can extract data out of this is by taking a look at each of those points and figuring out where they are on those two axes and then making a record of that. And I did that. It's tedious. So this is a good example here where for my goal of reconstructing the actual data, a table would have been much easier to work with. So if I just had a table of the results, I could take all the results, just copy and paste them, put them into Excel, and I'd be done. I love graphs, but I just want to point out that graphs are not always great for every single goal. So if you know a particular goal that your audience has, such as they're going to want the data and they're going to want to be able to run statistical analyses on your data, then you might say, hey, you know what, maybe a graph isn't the way to go. Maybe I'll also include a table of all the actual results. But anyways, they didn't do that. So dot by dot by dot, individual by individual by individual, I recreated their scores. And basically, you can see that if we just take a look at the aggressive behavior, forget about that face to width height ratio, we got some subjects with aggressive behavior scores kind of in the middle. And then we have other subjects, individuals, that have really low aggression scores. And then we got other individuals that have really high aggression scores. So how are those scores kind of spread out? What's the kind of picture that we have of just how aggressive these male individuals were? So what we're going to do is we're going to take a look at this data, this zoomed in data here, and we're going to see three different ways that you can get a sense of the distribution of this data. How is it spread out? How do they cluster together? What is the pattern that this data has given us? What is the actual way that aggression is distributed in a population based on this sample? We're going to see how you can extract that from these numbers here. Now, the first way that we're going to take a look at is called a stem plot. And I'm going to introduce the stem plot for one reason, well, for two reasons. Number one, you will occasionally come across them in older psychology research. So if you're kind of going back to the roots, if you want to find out the historical sort of first studies, which is a really good idea often because, again, these are the ones that are reported in textbooks and get distorted over time. If you go back to the older studies, you might come across a stem plot. So I want to make sure that you know how to read a stem plot. But reason number two is that if you are ever trapped on a desert island and your phone has died and you have no electronics whatsoever, and you have been recording the height of the tides and you need to know what the distribution of the tides is so that you can make an educated guess about when you're going to get into your raft and when you're going to go out there and try to escape this desert island. Remember this meeting today, because you're going to be drawing a stem plot, and those are really the only two reasons I can imagine why you would want to actually draw a stem plot or know how to do a stem plot. So on that note, remember me if you're ever in that situation. Mention me in your autobiography. But let's get on to stem plots here. All right, so to create a stem plot, it's pretty straightforward. First thing you want to do is you want to sort the data from least to greatest. This is just to make it easier for you to actually create this stem plot, because again, you're scratching this into the sand or onto a rock with your, on your desert island. So first you want to order all the aggression scores. So we got a low score of 52. We got a high score of 583. And then what you want to do is you want to decide which part of each number is going to be the stem. And what the stem is, those are basically the categories that you are going to put these numbers in. Those are like the bins that you're going to put these numbers in. And you don't want to choose too many stems, because that spreads out the data too much and you're not going to be able to see a pattern. You don't want to choose too few stems, because that's going to scrunch all the data together and you're not going to get any insights. So you want somewhere between at least 5, I would say, and then no more than 20, depending on your data. So kind of using that as a guide, what I did is I made stems of intervals of 50. So we're going to have, so first you want stems that can cover the entire range. So 50 is going to be the stem for all the scores that are from 50 to 99. 100 is going to be the stem for all the scores that are from 100 to 149. 150 is going to be the stem for all the scores from 150 to 199. And then finally, all the way down to 550 is going to be for all the scores that are between 550 and 599. And as you can see, our lowest score starts at 52. Our highest score is 583. This covers everybody. Everybody's going to get a place on this stem plot. So you put out your stems, and then the next thing you do is you draw a vertical line separating your stems from the leaves. And then you start going through each and every piece of data, each and every score of aggression, and determining where it is on this stem plot. So we take a look at this 52 here. And then what you will do is you'll take the last digit from each number and you put that as a leaf across from the stem where it goes. So 52 goes into the 50 stem. So we write a 2 there, and that displays that 52 in our stem plot. We do the same thing for 65. 65 goes into the 50 stem because it goes from 50 to 99. So 65 goes there. We take our 5, we pop it up on our stem. We're going to do the same thing for all the rest of the data between 50 to 99. Each of them, we take that last digit and we pop it up there as a leaf on that stem of 50. So then we go on to the next stem. And we say, all right, we got 105. We take that last digit. We pop a 5 up there. And the reason you typically only use the last digit is because you want the sizes of the leaves to be the same for all of the scores. So typically that is easy to do if you just take the last digit rather than taking both digits or taking the entire number. So we take the last digit for 105, we pop it up into that stem. 118 and 124, we're going to put those in that stem of 100 to 144. So we pop in an 8 and we pop in a 4. And then you would just continue doing this as you go through the entire data set. And eventually you would end up with a stem plot that looks like this. And this is giving you now a better picture of how these scores are distributed. So I don't know if it's because it's how our minds naturally work, or if it's because I've been looking at graphs where the quantitative variable is on the x-axis, but I find it a little easier to interpret this stem plot if I just kind of rotate it to the side there. So you can now see that for each of these quantitative values, for each of these quantitative stems of 50, 100, 150, 200, and so on, we have a certain height above it. And that indicates the frequency with which scores went into that bin, went into that stem. So we can then see that there were a lot of scores in the low aggression side of this distribution. So between 50, 100, 150, and 120, there's a lot of scores there. And then as aggression increased, the number of subjects with those aggression scores decreased. And you can kind of see that it kind of follows this curve here, which sort of gives you a good idea that on the whole, these subjects typically were not that aggressive, but there were fewer and fewer subjects as the aggression increased. And that kind of gives you this distribution here that you can sort of see better what was going on. Notice it's approximate. I mean, for some reason, there was a drop in aggression between 100 and 149. But still, it gives you that general idea of what the spread of this aggression score was across the 37 subjects. All right, so those are stem plots. Any questions about that? All right, so tuck that away into your memory banks if you're ever on a desert island. But I'm thinking most of your life is going to be spent where you have access to computers. So we're now going to take a look at two more ways of displaying quantitative data. And the first way that we're going to take a look at is called a dot plot. Now, dot plots are something we've already encountered. So this is going to seem a little bit familiar, but I just want to make sure that we get it down and we know exactly what we're dealing with. So in a dot plot, what it is it's a display where each data value gets a dot. And that dot is positioned above its actual value on a number line. So how do you make a dot plot? Well, once again, we're going to take the exact same data that we just displayed in a stem plot. And just for our purposes, we're going to organize it from least to greatest. If you're using a program to create the dot plot, you don't have to order the data. This is just for demonstration purposes. But the first thing that you want to do is you want to draw your x-axis, your horizontal axis, and you want to put the name of the quantitative variable underneath it. So we're going to draw our axis, and these are the aggressive behavior scores. So you want to label that so that we know what we're dealing with. And you also want to scale your axis so that the smallest value in your data set has a place on your axis, and the largest value on your data set has a place on the axis. So you take a look at the smallest value, it's a 52. You take a look at the largest value, it's 583. Our number line goes from 0 to 600. That's going to fit everybody. Everybody's going to have a place on this dot plot. So then the next thing that you do is you start plotting the values. So you take a look at that 52 and you say, all right, that 52 is going to get a dot. And that dot is going to go right above 52 on that x-axis. So that 52 turns into that dot that's right there on that aggressive behavior scores x-axis. And then you continue to do it. And you say, all right, next one, 65. That 65 gets a dot that's going to be right above the 65 on that number line. So that's right there. And then you continue going on. So let's do these numbers here. So from 70 to 124, each of those gets a dot on the number line. And you'll notice that we have that first double dot, and that is for the scores of 80 here. And because there's two scores of 80, because two individuals got exactly the same aggression scores, you get one dot for the first 80, and then you get a second dot on top of that dot for the second 80. So as scores are duplicated, the stack of dots is just going to get higher and higher and higher and higher. So this is a really quick way to see that, well, there's a lot of individual scores, but one of the scores has been duplicated. There's actually two scores that are a score of 80. And then we continue to do this with every single point of data. And eventually we would get a dot plot that looks like that. Now, this is an example of graphing your data, displaying your data, and then not being content with your first version of it and trying it to display it in a slightly different way. And what I mean by that is we take a look at this data here. And we want to know what the kind of spread is of this data. But looking at it, is really, there's nothing really that pops out at you. You can kind of see that there's a few more scores at the beginning, but you can also see that there's scores at the end, and your visual system is just not made to sort of parse out, is there a lot more at the beginning and a lot fewer, for the high scores, or is it not really that case? So if you ever come across a dot plot, if you ever create a dot plot and it looks like this, it's just kind of flat. What you want to do is you want to start grouping the data. And one way to do that is just to round it to a certain nearest number. So what I did in this case is I said, all right, we plotted all of these and they were the actual values. What would it look like if we rounded each value to the nearest 10? So when you round each value to the nearest 10, it starts to look like this. And you say to yourself, well, that's a little bit better. That's a little bit, now we can kind of see some clusters here. We can kind of see some isolated individuals at the higher ends. We can see more clusters of individuals at the lower ends. But it's still not giving us a kind of clear amount of, or a clear idea of what the data looks like. And I wish I could tell you that the correct number of sort of categories or bins that you can group your data into is like 10. I wish I could say that's the one to go for. But really, sometimes it's just trial and error. So we tried it individually, didn't really work. We rounded to the nearest 10, each score didn't really work. We're now going to round it to the nearest 50. And now you can see that things are getting a lot clearer. So in this case, 52 turns to 50, 65 turns to 50, 70 turns to 50, 80 goes to 100, 80 goes to 100, 92 goes to 100. So we're rounding to the nearest 50. And then once again, now we're starting to see and be able to decode a bit more of what the pattern actually is. And once again, we can see that most of the aggression scores were concentrated in that lower aggression score in the hundreds and the 200s. And then as you increase, there were still individuals that were scoring high, but fewer and fewer of these individuals achieved those higher and higher aggressive behavior scores. All right, so that is the dot plot. Any questions on that? All right, the last plot that we're going to take a look at, the last way to display your quantitative, single quantitative variable is called a histogram. This is by far the most widely used method of displaying a single quantitative variable. And we're actually not going to spend too much time on this for no other reason than it's basically a dot plot with a little bit of window dressing on it. So if you understand the dot plot, you're going to understand the histogram. So we're going to start with this dot plot over here. And we're just going to stretch it out a little bit so we can put in some more details. So when you're doing a histogram, you want to choose equal width intervals that span the data. So we have here the equal width intervals. We rounded everything to the nearest 50. So it's 50, 100, 150, 200, 250, 300. So we got those equal width intervals. The next thing that you want to do is you want to draw a label under the axes. So we have our x-axis, that is your aggressive behavior scores. And then we're going to have now a y-axis. And your y-axis is going to be your frequency, or your count, or your relative frequency. So we talked about frequencies and relative frequencies last time. So you could either have the actual count, or you can have the percentage or proportion of the values. We're going to actually use the frequency here. So we're going to label these, and we have a frequency of 0, 2, 4, 6, or 8. And then the last thing that you do is you put a bar above each interval, and the height of the bar indicates how many individuals got that score, or how many individuals have that particular score on your aggressive behavior scores. So literally, it's a dot plot where you build a little apartment building for every single dot. And the height of the apartment building is just enough to fit the dots. So these three dots here, these three dots here, they get an apartment building that's 3 stories high. And that indicates that in that grouping of 50 to, in that rounding to 50, there were 3 scores that rounded to 50. We over the score, the rounded score of 100, we have 7 scores. So we build ourselves an apartment building that is 7 stories high. Over the rounded 150 scores, we have 4 scores, 4 dots. So we build an apartment building that's 4 stories high. Over the 200, we got 5 dots, so 5 stories high, and so on and so forth, until you have a series of apartments buildings built, and we can't forget about 600 over there. And then again, this gives you a nice visual display of how those scores are distributed. So this again kind of lets you know that most of the scores are in the lower aggressive area, and then we have fewer scores as we get higher. This is kind of the first time that it kind of popped out to me. There seems to be a spike at 450, which indicates that that might be some really beneficial level of aggression to have, where maybe people with that level of aggression tend to be more successful. And then we have the one person over at 600. So again, this kind of gives you a nice look at the data. And again, it lets you speculate and kind of open up your mind to possibilities, like the thing that just occurred to me, that maybe an aggression score of 450 has some advantage where it's still acceptable in society and you're more likely to be successful in your interactions. And then one last note, I had to choose a color for this histogram, aggression, red. The two of them are culturally linked, so that was why I made the red choice. Again, not going to find that in a statistics textbook typically, but good way to communicate and help your reader out. All right, so those were the single quantitative variable, just the aggression scores. So we started with those aggression scores. However, if you remember, we had facial ratios. We had the width to height ratio, and we wanted to know are those associated with the aggression scores. So that's what we're going to be looking at now. And the only way you can see if those two are associated and display that is by displaying 2 quantitative variables at the same time. So does face shape predict aggressive behavior? If that's what we want to know, what we're really asking is there a relation between face shape and aggression? And in order to display that relation, we're going to need a new type of display, and that one is the scatter plot. So the scatter plot is the last thing that we're going to take a look at in terms of how to display quantitative data. So a scatter plot shows the relationship between 2 quantitative variables, but they're measured on the same individuals. So that is extremely important to remember. So here we have the 37 scores of aggression from that point subtraction aggression paradigm. And then before we can make a scatter plot, we also need the 37 scores for each of these individuals and their facial width to height ratio. So we need the scores for the other variable, which are right there. And now we can build our scatter plot. So it's important to remember that these variables on a scatter plot, they have to be from the same individuals. It only makes sense if they're from the same individuals. So when I put these scores into an Excel table, for example, and I'll zoom in on that Excel table, that score of 95 on the point subtraction aggression paradigm, that score, that aggressive behavior score of 95, that goes with this facial width to height ratio of about 1.5, and that's because they are from the same subject. So subject number 1, they measured his face, had a face width to height ratio of 1.534, and then they gave him the point subtraction aggression paradigm measure, and he scored a 95. Those are his 2 scores. That makes this score eligible for our scatter plot. That score of 70 goes with this score of 1.68 on the facial width to height ratio because they both belong to subject number 8. So you need to know which scores go with which other scores on those 2 quantitative variables. Otherwise, you have no way of creating that scatter plot. So that's the information that you need to start with. You need a certain number of individuals, you need their scores on one quantitative variable, and you need their same person's scores on that second quantitative variable. All right, so once you have those scores, you can build the scatter plot. I told you it would come back, and here it is. So we're going to end today by breaking this down just kind of piece by piece. So we know exactly what we're looking at. We know how to read a scatter plot, how to make a scatter plot, and how to use and deal with a scatter plot. All right, so step number one, you want to identify the variables and you want to label the axes. You want to put the name of the explanatory variable on the horizontal axis. So the explanatory variable is what you think is causing the other variable. It's what you believe is the explanation for the scores on the other variable. So in this case, they're trying to use facial width to height ratio to predict aggressive behavior. So they're hypothesizing that width to height ratio will explain their aggressive behavior. So that width to height ratio, that's the explanatory variable. That one goes on the x-axis there. The name of the response variable then goes on the vertical axis. So in this case, the response variable was how aggressive were they? So aggressive behavior will then go there on the y-axis or the vertical axis. So that's the case where there's a clear predictive theory going into the study. If there's no clear predictive theory, then you can put either variable on either axis. But if you do believe that, oh no, I'm looking at does this predict this other variable, whatever is doing the predicting goes on the x-axis, whatever is getting predicted goes on the y-axis. Next thing you want to do is you want to scale your axes. Again, you want to make sure that all of your data will fit on that x-axis. So the lowest and the highest face width to height ratios will be represented on that x-axis. You want to make sure that the y-axis is scaled in a way that all the scores of aggressive behavior can fit on that axis. And that has been done here very, very nicely. And then what you do is you take each individual score, you take their two scores and you plot them on the graph here. So subject number one has a face width to height ratio of 1.534. So you would find 1.534 on that x-axis. They have a aggressive behavior score of 95. You would find 95 on that y-axis. And then where those two coordinates intersect, that's where you put your point. So that dot is subject number one. So every subject gets their own dot. In this case, that dot right there, that is subject number one. We're going to do the same thing for subject number 8. So once again, facial width to height ratio of 1.68, aggressive score of 70. We plot those both on the x-axis and the y-axis. We end up with that dot right there. That dot right there, that represents subject number 8. And then what we would do is we would just continue to do that for all 37 of these scores. And eventually we would end up with a scatter plot that looks like that. And this scatter plot here is a visual representation of the data that we collected. It's a visual way to let us know, are these two variables related at all? And one of the things that you're going to want to do on your scatter plot, and we're going to learn how to do this next time, is not only do you want to put your dots on the scatter plot, so each dot for each individual in the study, but you also want to add what's known as a line of best fit. And this is a line, and again, we'll see how to do this next time we meet. This is a line that is the closest to all of the dots. So this is the best line that you can draw through this data where the distances from the line to the dots is minimized. So any other line other than this one would give you more differences than this particular line. So this is the line of best fit. And what this kind of tells you is it tells you the general relation between the two variables. So what we have here is we have what's known as a positive relation. That means as one variable increases, the other variable increases as well. So as face width to height ratio increases, aggressive behavior also increases. If we had a plot of the data for the female subjects, we would still have a scatter plot. We would still have individual dots all over the place. However, that line of best fit for the female participants would be a flat line. And if your line of best fit is a flat line, that indicates that there's no relation. That indicates that your facial width to height ratio does not at all predict your aggressive behavior. This line is not flat. This line is slanted. It's got a positive slope. And what that again means is that in general, as this facial width to height ratio increases, so did the aggressive behavior. All right, and then the last thing we're going to do is we're going to put a pin in this. And this is something that you always want to do whenever you're taking a look at data like this. And that is to try to state the relation that you have just discovered in a way that makes sense. So another way to think about that is if you needed to explain to your friend what this data is saying on an elevator, what would you do? So given this result that we just saw, given this histogram that we have access to, given this line of best fit, what would we tell our friend is going on in this data? And if you can do that, that is a really good indication that you understand what is going on and you have read the scatter plot correctly. And also you have put it in a efficiently communicated manner. Because I'll tell you right now, if you went to your friend and you said, well, as your facial width to height ratio increases, so too do aggression scores. Your friend is probably going to say, whoa, wait, what's a facial width to height ratio? And you would have to explain to them, well, do you know what a zygon is? And you would say, no, we don't. And then you would be, elevator dings, they get off the floor, they have no idea what's going on. So it's just good practice to take a look at a result like this and ask yourself, because you're not always going to be stuck in an elevator with a friend trying to explain to this, but just as a self-check to say, do I really understand what's going on here? Do I really understand the data that I'm looking at? Make sure that you understand each piece. And one way to do that is to take a look at the x-axis and say, all right, that's face width to height ratio. So what does a low score on width to height ratio mean, right? What does a low score mean? And it's sort of there, but it needs to be unpacked. This is the width to height ratio. What does that mean? That means width divided by height. So if you have a wide face and it's wider than the height of your face, you're going to have a very narrow face. If on the other hand, I got that backwards. See, this is why it's important. You're going to have, let's just put it this way. Low scores are a narrow face because you have a small width divided by a height. That's going to lead to a low score. So low scores are narrow because the width is small. High scores are wider because the width is greater, so compared to the height. So what this means is that the facial width to height ratio, a low score means a narrow face, and a high score means a wider face. So now you can say, instead of going, hey, yeah, that width to height ratio, you can tell your friend, you know what? As faces get wider, aggression goes up. And that makes a lot more sense. And if you can get to that point, like I just did, where it got to as faces get wider, aggression goes up, that is a good indication that, yeah, you've digested this, you have processed this correctly, you know what's going on. If you can sum it up in a way that makes sense like that, and that somebody who didn't have time to think about this can actually go, oh, yeah, that makes sense. And the next person that I see, if they have a wide face, I'm going to get ready for an aggressive interaction. But if they got a really narrow face, well, then I know that they're probably not going to be that aggressive. All right, so that is the relation between face shape and aggression. That was how to display quantitative data for a single variable in terms of your desert island plan of doing a stem plot, and then your computer plan of doing a dot plot or a histogram. And then if you're doing the relationship between two variables, we had that scatter plot. And then again, make sure that you can sum that scatter plot up in just one brief sentence, and that will indicate that you do understand and you have processed it correctly and you've got it down All right, any final questions, comments about this study or displaying quantitative data? All right, so that is it for our meeting today. Next time, we are going to start taking a look at distributions of data and furthering our elevator pitch skills in how to measure the center of a group of data, how to measure the spread of a data, how to locate outliers, and then also the relationship between two variables. We're going to take a look at correlation, and we're going to take a look at how do you determine what that line of best fit actually is. But that is all coming up next time. And other than that, we are done for today.